Which is more acidic and why? F CH2 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 COOH. This is one compound. CH3 CHF CH2 COOH. This is another compound. Let us see how these compounds dissociate. Now FCH2 CH2 CH2 COOH, it dissociates to give this carboxylate ion and H plus ion. Okay. Now if you see, in both the compounds there is fluorine, which is strong electron withdrawing group, means minus I group. If electron withdrawing group is there, it withdraws electrons and stabilizes the carboxylate ion. But in both the compounds we have same electron withdrawing group, but inductive effect is distance dependent. It decreases in minus I nature, decreases with increase in the distance of F from carboxylate group. So if I take 1, 2, 3, 4, 1, 2, 3, 4. So the negative charge intensity, if it is less, stability will be more. But here in the first compound, F is there on the fourth carbon atom. In the second compound, F is there on the third carbon atom. Inductive effect will be less with increase in the distance. So if the distance is less, inductive effect will be more. So second compound, the carboxylate ion is stabilized due to inductive effect more compared to the first compound, because F is on the third carbon atom in the second compound and on the fourth carbon atom in the first compound. So second compound is more acidic than first compound. Means 3-fluorobutanoic acid is more acidic than 4-fluorobutanoic acid. What is the reason there? Inductive effect is distance dependent. With increase in the distance, minus I nature decreases. If minus I nature decreases, stability also decreases. If stability decreases, acidity also decreases.